Today we're going to talk about combining like terms, but first we need to understand some vocabulary that goes along with expressions, and then we'll get started. I know that most people by now understand what a variable is, but surprisingly, people have trouble defining it. So you need to be able to really understand something, you have to define it. A variable is a letter that takes the place of an unknown number. Now that makes sense, I'm sure. Okay, an expression, it has no equal sign, so we're going to put a little star down here. Has no equal sign. If it had an equal sign, it would be an equation. Both sides would be equal. An expression is one-sided, and it's just a math problem with numbers, operations, and to make it algebraic, it has variables. Our next term is constant, and it's the one thing in math that does not ever change. Math has lots of rules, but then there are always exceptions to the rule. Well, this one never changes, and the only thing in math that does not ever change is just the number. Never changes. And you know how a lot of times if you have younger siblings, you'll say, oh, they're constantly getting on my nerves, which means they're continuing to do the same thing over and over and over, and it gets on your nerves. It doesn't change. All right, the next term we're going to talk about are the number of terms. And you count the number of terms in an expression. It's the parts of an expression. Of an expression separated by either an addition or subtraction sign. And I know that this is not going to make a lot of sense right now, but once we have the definitions of the terms, I'll explain how to pick them out from a problem or an expression. Coefficient, that is a really weird looking word, isn't it? And the coefficient is the number that is multiplied by a variable. It is only the number. It's not the number and the variable, it's just the number. Okay, and the last thing are like terms. Like terms are constants. And remember, constants are just plain old numbers. Or they are variables. Oops, no, sorry. It is the same variable raised to the same power. All right, so now let's practice using those definitions. Over here we have an expression. Do you see it has constants, has a constant, it has addition, subtraction, has variables, so we're good to go. What are the variables in this expression? There are two. Variables are your letters, so it's just M are. Constants are just the plain old numbers. Well, that's not a plain number. That is. That's not a plain number, and that's not a plain number, and that's not a plain number. Next term, coefficient. That's that really weird word. It is the number that is multiplied by a variable. So we look for multiplication, and the most common way to show that is when you put the number right beside the variable. So the first coefficient that we have is a -12. The sign in front of the number goes with that number, guys. Don't forget that. Sign, oops, sorry, in front of a number goes with the number. The sign in front of the number goes with the number, just like when we first learned about integers. Okay, so this is the first coefficient because that's multiplying -12 times m. That's not a coefficient. We're multiplying 18 times r. Look at your sign. It's a positive 18. We're multiplying 3 by m, and it's a positive 3. Now there's a blank, and the only piece that we haven't talked about is right here. But all variables technically have a coefficient. If you have an r squared, how many of them do you have? I hope you said 1. So there is an imaginary 1 right there, and it will be a positive. Okay? That will be a little tricky at first. All right, number of terms. That's the pieces of the expression separated by a plus or a minus sign. So we have 1 piece, 2, 3, 4, 5. You're counting the pieces, not the signs themselves. So there are 5 terms in that expression. I want you to pause the video, come back in a minute after you have done number 2, and let's see how you did. Welcome back, and you may need to pause the video again to check your answers, but I did want to talk about one piece that's a little tricky right here, the constant. Now just because there's an exponent doesn't mean that it's not a constant, because -8 squared tells us to do -8 times -8 to get a positive 64. So that is a constant. It's a plain number. So that would be a little tricky if you didn't pay attention. All right, now here comes the fun part. This says to simplify. Right now we just have a whole pile of fruit. Now if you were explaining the fruit that you had to a friend, would you say, I have a strawberry, a banana, a strawberry, a banana, apple, a banana, a strawberry, a banana, an apple, and an apple? I didn't think you would. All right, so you would tell somebody, you would group them together. You would tell someone, I have 1, 2, 3 strawberries. So if you have 3 strawberries, tell them that. And then for bananas, you would say 1, 2, 3, 4, 5, 6 bananas. And 1, 2, 3, 4 apples. And we're going to have our variables represent each piece of fruit. So instead of saying 3 strawberries, we're going to use S for strawberries. Oh heavens, that's horrible. We're going to use the variable S. For bananas, you guessed it, we're going to use a B. And for apples, we're going to use an A. Now to simplify this, you wouldn't say, oh, I have 3 plus 6 is 9 plus 4 is 13. You don't have 13 of anything. Because if you look over here, there's not. So the way you would talk about it is you would say, I have 3 strawberries. I have 6 bananas, and I have 4 apples. And to put it all together in math, that tells us that we're going to be adding. And that is how you simplify it. we just combined like terms, guys. We got all of our strawberries together. We got all of our bananas together. And we got all of our apples together. Thinking about it, it's kind of like sorting. And you have to sort them into groups of things that are the same, which are your like terms. All right. Now that's a pictorial view. Here we just have a list of terms, and we need to find the ones that are like. Let's review that definition real quick. Like terms are constants or the same variable raised to the same power. That's important, guys. All right, let's take a look. We have any constants? Yes, we only have one, so we don't have anything that's like that one. Do we have variables? Yes. Do we have any of the same variables? We have C's and D's. Well, these will not be like. These are C's, these are C's, these are C's. Okay, but the definition said same variable, well, we check that, raised to the same power. Well, hello. We have a plain C and a C squared. They don't have the same power. So these two are not like terms. These are not to the same power, but the 4C and the plain old C are like terms because they have the same variable to the same power. You don't even need to worry about the coefficient. Okay? All right. Let's look at the next one. Do we have any constants? Why, yes, we do. I hope you found them. We have 8. No plain numbers, and hello. There we go. So 8 and 23 are like terms. Now let's see if we have anything else. We have, remember, you don't need to worry about your coefficients. Only look at your variables. These two, we have 3y's. Now, once you've determined they have the same variable, you have to check the powers. This is y cubed. That is y squared. They are not like. This one is y cubed. This one is y cubed. So that would mean this term and the sign in front of the number goes with the number. So negative 7y cubed and 2y cubed are like terms. This is an important concept when you're looking at simplifying expressions that have lots of terms or only 2 terms. When we're talking about algebraic expressions, you've got to look at the variables. Simplify means to make as few terms as possible. Usually people think of fractions when you hear the word simplify. In this case, though, we don't have fractions. We have expressions, and we want to get them down to as few terms. Right now, this one has 2 terms, and we're going to see if we can make it down to 1 term. Sometimes you can't simplify it, and, you just write simplified and move on. All right, so we're looking for like terms. That's the key, guys. We're going to combine like terms. Alrighty, so we have some A's and we have some A's. Those are like terms. So I want you to circle the term and the sign if it has one. Circle this term and the sign in front of it, because the second term is going to tell you whether or not you're adding or subtracting. Alright, when we have 2G's plus 2, oh no, those are A's, 2A's plus 8A, that would be like our apples over here. Okay, so we have 2 apples plus 8 apples. That will give us, you got it, 10 apples. And you're done. We went from 2 terms down to 1. All right, now let's take a look over here. We have no constants. We have A's, B's, and A's. Both of these A's have no exponents, so they're the same. So those two would be like terms. So you're going to circle your 5 A's. You're going to skip over that B, and you're going to circle 3A. Oops, not just any old 3A. The sign in front is negative. So 5 apples minus 3 apples gives us 2 apples. And the only thing remaining, the last term, is by itself. So I'm going to mark it, because when you're done, you want every term in the expression to have a mark, so that way you know you have used all of them. The shorter ones, it's not as common to get confused, but when we get to these long ones, it will be confusing if everything doesn't have a mark. So since we can't do anything with that, we're going to bring it down. And we went from 3 terms to 2 terms. It is simplified. 2A plus B. We can't add apples and bananas and come up with 3 of anything. And every year I talk about this. They say, oh, we can make a smoothie, but you don't have 3 smoothies. So that's why it would not make sense. All right, moving on to the next one. This one could be a little tricky if you're not very careful. First, I like to look for constants. Do I have any constants? I do, and it's raised to a power. So this is 4 squared. This is not -4 squared. We've reviewed this before when we were doing order of operations. In order for the exponent to go to the number and the sign, it would have to be in parentheses. So 4 squared, you can do in your head. That's mental math. 4 times 4 is 16. All right, so we took care of that. We don't have, oh yes, we do have another constant. We'll get to that in a minute. I like to try to take care of any exponents, and that's what you would do to follow the order of operations anyway. So that's a good thing. Now, you're going to go from left to right. Don't go out of order now. We just want to get rid of any exponents on our constants, and now move left to right. We have the first term with a variable of m, constant, another variable of m. So we're going to have to combine those two. So to combine them, we're going to circle it. And we're going to skip this because they're not like. We're going to circle the 5m and the negative. Now we're going to look inside. We're going to start using our integer rules. So when you look inside, we're going to have a -16 combined with a -5. Well, when you put a -16 and a -5 together, same sign. You add and keep the sign. That would be -21m. Then we're going to look at our next term. We have a +16. So I'm going to use a different symbol because it's not like those. Some people like to use different colors. I'm just trying not to waste your time with me switching pens so much. And we have a -16. Well, +16 and -16, when you combine those, they cancel out. So just mark them out. You don't even need to write the 0. If you did, guys, if you wrote -21m plus 0, oh, you can't see that. Let me fix it. -21m plus 0, this is 2 terms. It's not simplified. You can keep going. If you kept going, -21m plus 0 is just -21m. Okay? That is not simplified. And not in simplest form. Okay? If you just cancel out up here, then that saves you all of the steps here, and hopefully a careless mistake is avoided. The answer is -21m. Alright, I want you to pause the video and give number 8 a shot. Okay, welcome back. This is not the final answer, but I decided after I let you work on this one by yourself, I wanted to talk to you about the second term. So to combine the A's, we have a +5 apples and a +3 apples, so that makes 8 apples. But if you just write that there's no sign in between your two terms, and you need to put one. So since your answer was a positive, you put a plus. And we have -8 bananas plus 8 apples. And you are finished. In 7th and 8th grade especially, they do like you to write your variables in alphabetical order. So if you were going to do that, it would be 8a minus 8b, because the sign here. Right now I'm not so concerned about that, but in other higher level math classes, they're going to ask you to do that. All right, now the next one looks a little daunting because this got how many terms? 1, 2, 3, 1, 2, 3, 4, 5, 6 terms. That's a lot. So you're going to take your time, look for your constants that may have an exponent first, and we have one of those. Plain old number, so 3 squared is 9. We're going to move on over here and look for the variables now. Go left to right. We have k squared and a k. Are these like terms? Same variable, but not to the same power. So now, k squared and k squared. All right, so we have these k squares, and we have these k squares. You've got to be very careful when you're doing your circling so that you don't mark over something where you can't read it or that you can't see the sign. These are k's, but not k squares, so we can't circle it. All right, combine these two, so we have the same sign. You're going to add and keep the sign, so that would be -11k squared. Now move on to your next term. We have plain k's and plain k's, so those will be like terms. Remember, use a different symbol, and you're going to make sure you include the sign in front of the number. So we have -4k minus a k. Now here's where that imaginary 1 comes in, guys. It goes right there, because what is 1 times k? K. But you have to really realize there's a 1 there. People get confused when they don't put the 1 at first. Later on, you won't need to write it. And in your final answers, it's better if you don't write it. It's technically not wrong, but better not to. Alright, so look at your signs. We have a negative and a negative, so we will add and keep the sign. That would be a -5k, or you can call it -5k. It's the same thing. And as you see, we have 2 terms left. Are they like terms? Why, yes they are, because they're constant. So you're going to need a different symbol. You could try a triangle or something. I'm just going to use a little cloud. So we have 9, and it's a positive, plus 5. 9 plus 5 is 14. And since it's a positive 14, you're going to put a plus in the middle. K squared, k, and a constant. We have no like terms left. Everything has a mark, so you know you've looked at each part. And that is your simplified expression. Okay, we can use expressions in geometry as well. It says to write and simplify an expression to find the perimeter. Remember that perimeter, you're going to add all sides. So since a rectangle has 1, 2, 3, 4, you've got to add 4 things. But we only have 2. So you have to also remember that opposite sides of a rectangle are congruent. So if this side is A, this side is A. And if this side is 3b plus 5, then this side is 3b plus 5. So we can add those together. And a lot of you could do the plain variables mentally. We're going to add 2 of these together. They're the same thing. You already know that. 1a plus 1a is 2a. If not, you would need to write, oh, this is going to be kind of long, a plus a. That takes care of these 2. And now I have to write these 2. plus, because it's perimeter, add everything together, 3b plus 5, plus the last side, 3b plus 5. Now you're looking for your like terms. Don't forget about those imaginary ones. We have 1a here and 1a here. No other a's. So we have an a plus an a. That gives us 2a. Now let's look for the next term, b's. It's not a b. Oh, there's another one. We have 3b plus 3b to give us 6b. And our last two terms are constants. So we have plus 5 and plus 5, which would be a plus 10. That is the perimeter of our rectangle. I hope I've helped you to understand a lot of the vocabulary associated with expressions and how to combine like terms.